Welcome to Brain Vision.
So in this problem, we have an acceleration of 0.379 g, and then when we plug in for what g is, we are able to get an acceleration on Mars of negative 3.71 meters per second squared. We're also told that the time for the object to go all the way up and then all the way down is 8.5 seconds, meaning that the time for the object to go only up is 4.25 seconds, half of the 8.5. The unknown for part A is x minus x naught, the total distance traveled on the way up, but I actually think it's easier to find the initial speed that the object is given first, because we can use this kinematic equation to find that real quick. V is equal to v naught plus acceleration times time. Now at the top, v is going to be 0, because it's stationary for a moment when it's at the very top. V naught is the unknown. A is negative 3.71, and t is 4.25. This gives us a value of v naught is equal to 15.77 meters per second. Now that we know what v naught is, we can use this kinematic equation to determine what the distance traveled on the ascent is. So we get x minus x naught is equal to 1/2. Since v is 0 at the top, this is equal to 0. So we just have v naught, which is 15.77, and then t is still 4.25. This gives a value of x minus x naught is equal to 33.51 meters. And so I believe this is the answer to part A, and this is the answer to part B, but we still need to graph. And so I actually think it's easiest to start with a graph of A versus t. Since we calculate at the very beginning that A is negative 3.71 and it's not dependent on time, that means the graph is just a horizontal line at negative 3.71. Now, we also calculated that the initial velocity is 15.77, and the velocity on the way down is going to be the same, except it's moving down, so we have it be negative 15.77. We know in the middle, when it's at the very top, the velocity is 0, and that happens at 4.25 seconds. And so you can either draw a straight line through those points, or you can recall that the graph for velocity is the integral for the graph of acceleration, and the integral of a constant is just a line, a straight line. And so we get something that looks like this. The integral of this line yields a parabola. Since the slope of this is negative, it's a downward facing parabola. It opens up downwards. It also makes sense with the position because we know the object goes up and then it comes back down. The maximum height of the object we calculated was 33.51 meters. And so that's the x value here at the apex. And then the time at the very end here is the full time of the transit, which was given in the problem as 8.5 seconds. And that's it.